So here's the practice final, question number 23. In statistics, what does DF denote? That is the degrees of freedom. If a simple random sample of 25 speeds of cars on California Highway 405 is to be used to test the claim that the sample values from a population with a mean greater than the posted speed limit of 65 miles per hour, what is the specific degrees of freedom? Okay, so we're just looking for whatever the sample size n is, and they were a sample of 25 speeds. The fact that it's California Highway 405 is just a distractor. You can ignore that. And the degrees of freedom will be n minus 1. So if this is n, the degrees of freedom will be 24. So df denotes, I think it's right here. df denotes the number of degrees of freedom. For this sample, it's 24. Incidentally, there are, in the approved notes, let me go there. Oh, if I can find them. You have the statistic symbols. And if my memory serves me correct, that is one of the symbols we have listed. Okay, it's on the second page, and it's not italicized, but DF stands for the number of degrees of freedom. How do you know if it's going to be n minus 1 or n minus 2? You got to remember what you're dealing with. In this case, it's n minus 1. Number 24. Use technology to find the p-value for a two-tailed test with n equals 12 and a test statistic of t equals blah, blah, blah. So we know we're using the student t-distribution. It's kind of indicated too by the fact that the n value is less than 30, and we know nothing about the parent population. But because the test statistic was a t-test statistic, it indicates we will definitely be using that. So I'll go ahead and use StatCrunch since it's here. The TI-83 can do this, yep, and the TI-84 can do it also. So I'm going to go to the calculator. I'll choose a t-distribution. My degrees of freedom will be 11 since n was 12. Excuse me. And if I'm going to find the p-value, I need to go, let's see, what was it? It was a two-tailed test. Okay, so this test statistic fell to the right of center, and that is where I come to this little thing, this flowchart. What type of test is it? Two-tailed. Is the test statistic to the right or left of center? It's to the right. So I'm going to find twice, I'll double the area to the right of the test statistic. So let me get that out again. It was 2.829. That's that tiny amount right there. So we're going to double that, and it'll be 0.0164. Actually, I like to use the calculator on this if I happen to have it. Or I guess I was trying to say that in such a way that I was meaning if you happen to have it. So I would do second vars, go down here to TCDF. So it'll use the student t distribution, and it'll be a cumulative calculation here if I give it the right information. Now the TCDF, actually all the calculator reminders are on one of your handouts that you're allowed to use here. I believe there's the normal distribution. Maybe not. Shows you how to do the whole hypothesis test, but maybe it doesn't show you that specific one. I definitely know that it is in the graphing calculator review card, the statistics calculator review card. So, you can look that one up. That's also one of your approved ones. So if I remember right, though, I'm going to put in the left endpoint and then the right endpoint. But since I'm just trying to go extreme, and actually I'll get that picture. Maybe that's an advantage to StatCrunch, is that it gives you a nice little picture to look at. I'll get that picture for a visual. If we're trying to go extremely right here, then we are going to say something like 99999999999. And then you need to state the degrees of freedom, which are 11. I think that's all it needs. So it gives you that, right? Okay, why did I say I like this? Because on this one, if it wasn't such an easy number to double, I could put it in a calculator and double it or something else. But what's cool about this is I can just hit times 2 now, since it was a two-tailed test, and there I doubled it. Or I could have typed it all in at once by hitting 2 times, then call up the function. And use your endpoints. Remember, you need the degrees of freedom on this. So now I'm already doubling it. Next question. Number 25. Assume that a simple random sample has been selected from a normally distributed population. Okay, nice. And the test test the given claim. Identify the null and alternative hypothesis, test statistic p-value. Okay, so just do all the work. Okay, in a manual on how to have a number 1 song, it is stated that a song must be no longer than 210 seconds, so basically 3 minutes. I don't know if that's true, by the way. Some of my favorite songs definitely are longer than 3 minutes. A simple random sample of 40 current, by the way, that was just anecdotal though, so what if my favorite songs are greater than 3 minutes? Anyway, simple random sample of 40 current hit songs result in a mean length of 219, so their average length is 219, which looks like it's lining up there, and a standard deviation of blah, 54.3. Use a 5% significance level and run this test statistic, or run this hypothesis test. Okay, so if I was doing it during a test, I might do it differently than I will now, but I'm going to take my time to write out the claim. And it looks like a child's writing it, but I guess that really is me. This is a claim about the mean. I'm sorry, about the population mean. That a hit song can be no longer than 210 seconds. So it's at most 210 seconds. All right, well, that is the statement which contains the equality. So in this case, that's actually the null. And if that contains the equality, I want to, well, either way, I want to write the logical opposite of that. So if that's not true, we would be strictly greater than 210 seconds. I will then identify, there's my null, and my alternative. Remember that the alternative tells you what type of test you're going to do. Since this is a greater than, you can think of it like a little arrow here when the variable is written on the left, and it points to the right. But you can also just think about what the curve would look like. It's a right-tailed test. And so that's really all I need to to run this. If I'm going to use StatCrunch or the calculator, I'm going to get this all done at once. I'm going to go in pieces, though, to help explain the process, explain what these things are. So the question is am I going to use a t-distribution or a z-distribution? Well, my parent population was stated, not here, stated up here, that it was from a normally distributed population. Okay, so that's good. And I'm going to think about, I'll actually get the flow chart out for you here. So here's the flow chart where it says, start by asking yourself, is sigma known or unknown? So is the population standard deviation known or unknown? Well, this is a simple random sample of 40 current hits, so this is a sample. All throughout this sentence I'm talking about the X bar sample mean of 219 seconds. I'm talking about the standard deviation S of 54.3 seconds. And then I read on. It doesn't look like I actually know the population standard deviation. I know the sample standard deviation. So is sigma known? No. Now I'm over here. Is the population normally distributed? Yes, I already referred to that. But even if it wasn't, our sample was 40, so we would still end up in the t-distribution down here. That's one way you can choose that correct distribution. There's also, this is the formulas page. There's also this tool where you just, you choose the t-distribution if sigma is not known and the parent population is normally distributed, or n is greater than 30, which we satisfied both of those, so we're definitely using t. And the review card, again, actually I'll scroll up. Here's the part of the page. This is the second page where it's talking about hypothesis testing. And then on the third page, we've got choosing between z and t, and it says, is sigma known or not known? Well, down here, sigma is unknown, and then you use t. Okay, so I'm going to use StatCrunch to go to the t calculator. Since my sample size was 40, I have a degree of freedom of 39 degrees of freedom. I need to find out my test statistic though, don't I? Now this is going to be a right tail test, so I'm going to go greater than once I get my test statistic. Do you remember how to calculate that? I can look in here. This is hypothesis testing for 2. Hypothesis testing for 1 sample. It is right here. Right? Also, if I just remember that this is section, I believe it's 8.3, 8.4. So if I can remember, it comes from chapter 8. I could come here and I could use this. Right? The notation is a little bit different. See how this is using the mu sub x bar, kind of making its reference to how the central limit theorem applies and allows this to happen. This just says mu. That's fine. Okay, so I'm just going to calculate that. These parentheses aren't really necessary here because my calculator is a scientific calculator. It can do it, but I've got x bar of 219 from the sample minus what I'm assuming to be the population mean, if it's true according to this manual, then divided by, I'll use parentheses to make sure that it follows the order of operations. 54.3 is s divided by the square root of n, and that's not the degrees of freedom, that's n, so I'm going to use all 40. Maybe hit square root, which is right there. Close those parentheses right there, and hit equals. So I've got 1.048. So my test statistic is 1.048. It's a right-tailed test, so I want to look at the distribution, the t-distribution, and find out how much area. I'll use green for this. Falls, let's see, right. Let's just make it look like right there. Falls more extreme to the right. Now, if my critical value is on the left side over here, then I'll have a greater greater alpha. In other words, my p-value will be less than alpha. If it's on the right side, I'll have a smaller critical region, so my p-value will be greater than alpha. Well, let's get the p-value. So I can use the table here. Okay. I'm sorry, this will give me the critical value, not the p-value yet. I'll use technology for that. So the level of significance is 5%, and all 5% is going to be in one single tail because it's a right-tailed test. It's not a two-tailed test. So the area in one tail, 5%, when my degrees of freedom are 39. Oh, I don't have 39. I've got 38 and 40, so I've got a round, and rounding would take me to 40. 1.684. So 1.684, it's going to be somewhere around here. And that means that my p-value should be bigger than alpha. Okay, keep in mind, alpha is 5%. What is this p-value over here? I'm going to use the technology I already got open. 39, 1.048. Compute. And I've got 15%. So I'll just go ahead and copy this one. Well, 1505. Okay. Remember the way the process works. We ask ourselves, I'll actually just take us to the card. We ask ourselves if the p-value is less than or equal to alpha. If it is, then we follow the decision criterion to reject the null hypothesis. It's not in our case. The p-value is 15%, alpha is 5%. So if it is not, then we fail to reject. So we're going to fail to reject. Because the p-value is greater than alpha. Fail to reject the null. Now, what does that mean about the original claim? Well, it depends on if the claim was the null or it wasn't. The claim was the null. You see that here it contained the equality, right? We're just looking for that testing point right there. So we just ignore the less than part and we're looking at the equality. So that is where the null was. So I can use the chart for my final wording, or I can just remember from maybe the table. Let's look at both. Does the original claim include the equality? Yes. So I'm going up and down this column. Did we reject the null? No, we failed to reject the null. So there's not sufficient evidence to warrant rejection of the claim that. That's not saying that we support it. It's just saying that we are not going to reject the claim that, and then whatever we had said. If I wanted to, I could have gone here to use the flowchart. Does the original claim contain the equality? Ours did, yep. Did we reject the null? No. So there's not sufficient evidence to warrant rejection of the claim that to have a hit song, you better go less than 210 seconds. Now I just put everything in since I've scratched it all out. Now if you're using StatDisk, it actually gives you from the top to bottom final wording. StatCrunch can do almost all of that. Here, I'll show you StatCrunch. I'm using t-statistics, one sample with summary. The sample mean was 219 seconds. The sample standard deviation was 54.3, I think. Yep. The size was 40. It's a hypothesis test I'm performing, where I am assuming that 3 minutes is the best, and it's a right-tailed test. So our test statistic was 1.048, which is what we already saw. Our p-value is 0.1505. That's greater than 5%, which is what we were using as our level of significance, which means we would fail to reject the null, which then means that we would not have enough evidence to warrant rejection of the claim, because the claim in this case was the null. You can use StatDisk. Now if you're going to use StatDisk, make sure that you're using one of the rooms, because one of the rooms where you're going to test in doesn't have it and the other one does. Alright, so there's our statement. There's our test statistic. Our p-value. Critical value or values. Only one value here because all of our 5% level of significance is in one tail. Let me go to the. So remember that I looked this up. The 1.684. We failed to reject the null. Let's see if this is the right one. So there is sufficient evidence to support the claim. No, not that strong of a statement. There is sufficient evidence to support the claim that the sample population. Yeah, we should end up right here. There is not sufficient evidence to reject the claim, which isn't actually saying support. But it looks like they're only giving us that wording. There is sufficient evidence to support. That's all they give us. So I'm going to have to go with that. So there is sufficient evidence to support the claim that the sample is from a population of songs with a mean length greater than. No, the claim wasn't even that it was greater than. So maybe I should read this. There is insufficient evidence to support the claim that blah 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 with a meaning greater than. Did I mean it wrong or read it wrong? Yeah, right. There is not sufficient evidence to reject the claim. So there is insufficient evidence, same thing as saying not sufficient, to support the claim. That's not saying the same thing. There is I think they are just giving a statement too strong here, and they are saying there is sufficient evidence to support the claim, kind of like saying there's not enough evidence to reject it, so we're kind of supporting it. But that's a little inappropriate. What do the results suggest about the advice given in this manual, which said if you want to have a hit song, you got to have a song that's less than 210 seconds? So suggests it's a good idea, right? Results suggest that the advice of writing a song must be no longer than 200 seconds. Is not sound advice? No. The results suggest that no. I am really sorry to do this to you. It's a little too late at night to probably be doing this, but I just realized I stated the claim up here, but actually the claim was this, right? Because it reads test the claim that the sample is from a population of songs with the mean greater than. So it still is a right-tailed test, but and I still have the same test statistics, still the same critical value, still the same initial decision. The decision criterion is if the p-value is less than or equal to alpha, we would reject null, but it wasn't, so we failed to reject null. But then my final wording has to change, because does the original claim contain the condition of equality? No, it doesn't. Did you reject the null? No, we didn't. There is not sufficient evidence to support the claim that it's greater than 210 seconds. And now this makes more sense why they were giving us those options. So there's insufficient evidence to support the claim. We want to be right here. There's not sufficient evidence to support the claim. Sorry I'm flipping around so much. A little too tired right now. But there we go. Okay, so if that is what we were saying, there's not enough evidence to support the claim that that the sample is from a population of songs with a length greater than 210 seconds. So I'll go with this double negative here. The results do not suggest the advice of writing a song longer than 210 seconds is not sound advice. And we'll submit for these 3 questions. Oh, I should have rounded that to 2 decimals. Funny thing here is I wasn't even paying attention. It says it's got the Minitab, which is another, software that's already calculated the numbers for us. And they've already got the test statistic right there, t equals 1.05. So, and if I would have just read it, I would have rounded it. The p-value was at 15%. It said around 3 decimals, and even then I should have did 0.151 if I was reading those directions, but it's already been worked out, so we could have just used the accompanying Minitab display. But our final conclusion here: fail, reject, null, sufficient evidence to support the claim, and the results do not suggest this double negative that it's not sound. That was fine. So in essence, we were there. I just need to pay attention to my rounding here. If it was the difference between a pass or fail on the test, and that was an issue, you should certainly bring that up to me, and we can talk about it. Okay, anyway, I need to get to bed, so hope this video helps. It looks like this one got a little long on me.